Hello ninth class. Today we are going to study about studies of gas laws. In this we will be learning behavior of gas under changes if temperature and pressure are changed. Before that we will study about certain characteristics of gases which are being discussed in kinetic molecular theory of gas. We all know that all gases are made up of large number of extreme small particles called molecules, and these molecules have different behavior under different conditions when temperature pressures can be changed. So on that basis, kinetic molecular theory of gases was formed, and which gave that all gases are made up of large number of extremely small particles called molecules. So whenever we are talking about a gas, except noble gases, all other gases are in molecular form. If you are talking about, somebody is talking about nitrogen gas, means N2, not nitrogen N. If somebody is talking about oxygen gas, it's not oxygen, it is O2. Molecular form, okay? When we are talking about noble gases, we are talking about monoatomic. So be careful in that case. There are large vacant spaces called voids between the molecule of gas. That means in between the molecules of gases, there is a large gap. So volume of molecule of a gas is considered negligible as compared to the total volume of the gas. We consider that one molecule of oxygen volume is negligible as compared to the complete volume of that cylinder in which oxygen gas is filled. Molecules of gas are always in constant rapid random motion in a straight line in all possible directions. When they are moving constantly and randomly in all possible directions. Then molecules are perfectly elastic. So there is no net loss of energy during molecular collision. When these molecules are moving from one side to another, they are striking the neighbor molecules, they are striking the wall also. But they are elastic in nature. After striking, they don't stick there, they rebound back. What happened to them? They rebound back. Yes, that is what is their nature? They are perfectly elastics. And when they are not sticking somewhere, the energy is not lost. So the all total energy of the gas molecules in that container remains constant. There is negligible force of attraction between the molecule of a gas. If we are considering that large number of molecules are there, these molecules do not get attracted toward each other. They do collide, but after their collision, they move in different directions. So there is no attractive force of attraction between them. There is no effect of gravity on the motion of the molecule also. When these molecules are moving, they are never under any attractive force of gravity. They are free to move in all possible directions. Then we are talking about kinetic energy. The average kinetic energy of the molecule of gas is directly proportional to the temperature of the gas. Kinetic energy is directly proportional to the temperature in Kelvin. Now coming to another one, that is the pressure. We studied earlier that the molecule of gases, they are moving in all possible directions. So when they are colliding and bombardment of these molecules take place on the walls of the container, more is the molecule colliding with the container, more is the pressure. So we talk about pressure of a gas. So we say that the pressure of a gas is only due to the bombardment of molecules of gas. Understood? More is the bombardment on the wall of the container, more will be pressure. Or vice versa, less is the bombardment of molecules of a gas on the wall of the container, less is the pressure. So a pressure of a gas is directly proportional to the bombardment of molecules. So these are certain points which we learned from kinetic theory. Now there are certain characteristics which we have learned earlier. We said that gas don't have definite shape, they don't have definite volume. Now why it is so? The molecule of a gas are in state of rapid random motion and the attractive force between them is negligible. So when there is that means the intermolecular force of attraction is very weak. So molecules are not held at one position. they keep on changing their position. Okay, they keep on changing their position from one form to another. So gases can occupy whole space available to them. You take a small bottle of scent, scent is present inside that bottle. So when you press the knob, the gas will come out from there. Scent gas will come out from there. Within a second, that gas molecule will be felt all around in the room. They will be felt all around in the room. That means they had occupied the space, whatever was there of the room. Now coming to the gas have low density. In a gas, the molecules are far away from each other as compared to solid and liquid. Therefore, mass per unit volume in molecules, gas is very, very small. Hence, the gas have low density. Gases are highly compressible because in between the molecule of gas there is a large space. So, if we try to press them, they will come closer. So, we'll say gases are highly compressible, highly expandable also. If you start heating the gas molecule, so what they say, when the pressure on the gas is decreased or temperature is increased, the molecules will start moving away from each other. Hence that volume of gas can increase, they can expand. Gas exerts same pressure in all direction. If we talk about the molecules, they are moving in all possible random direction. We can't say that all the molecules are moving on the south wall or they are moving toward east wall. No. The movement of molecules is equal in all and every direction. So we can say that gas exerts same pressure in all directions. You might have seen balloon. You're filling during a birthday or some function, you are filling air in the balloon. What do you see? Is it swelling from one corner? No, it is forming a curve like structure, increasing. The wall of the balloon starts increasing because of elastic nature in all possible direction. Whenever gas molecules strike the wall of the vessel, it exerts some force per unit area called pressure. So the pressure which is been given per unit area of the wall will be equal in all direction. The last point which I want to discuss today, that is about gas show diffusion. Molecule of gases are always in motion and they have large vacant space between them. So if two gases are mixed together because of their high speed, low intermolecular force of attraction and large vacant space, they mix with one another. The gas shows the property of diffusion. This is known as diffusion. The perfume spread throughout the entire space in a room in no time as perfume molecule diffuses into the air molecule.